turn on pace. Okay, so for number 7, I'm getting a magnitude of 1,046.668 newtons, and the direction that would be in would be 31.156 degrees. So if you're not getting those numbers, or you're struggling to get those numbers, you need to see where you went off. Alright, so I would say my picture would be, you can make a picture that looks like in real life where you can see both forces on that object. But for vectors, I tend to say, I'll call this one vector 1, 50 degrees, at a magnitude of 900, 50 degrees, 900. And then I put the second vector at the start of the first, or at the end of the first vector. So it was 350 newtons at a negative 25 angle. So now I can see I started here and I ended here. So that's the result of those two vectors. And how much force is behind that would be its magnitude. So that's where I'm going to get that. And the angle that it's creating, I can care about that too. So I'm also going to show how you get to that. Alright, so this first vector is pulling it right and up. How much is going right and how much is going up is going to come from its component form. So 900 cosine of 50 degrees and 900 sine of 50 degrees. Then this vector is pulling it more right and then some down. So it can be calculated by doing its component form. 350 cosine of negative 25 and 350 sine of negative 25. And if I want to figure out what's happening with both vectors, I want to consider both of them. I want to combine them together, which is addition. So how much this one went to the right plus how much this one went to the right is how much my resultant vector will be going to the right. So 900 cosine of 50 plus 350 cosine of negative 25. And in a minute, I'm going to store that in my calculator as x. So that's going to represent how far the resultant vector is going to the right. If I add how much this one went up, and then add how much this one's bringing it down, add those together, and in a moment, I'm going to store that in for y. So that would represent this, the result of adding both those together, but it's their vertical component. So my x and my y are going to be like the two legs of a right triangle. So when I store these, define the hypotenuse of a right triangle, I could do Pythagorean theorem, and that better come out to that, so that's what I got as an answer. And the directional angle, I could do inverse tangent of opposite over adjacent, and that's where that answer is coming from. So I guess I'm actually not going to go ahead and store them because I checked this last year, but if you're having trouble using the calculator, I can kind of show you individually. Now for this question, I wasn't too concerned about those angles of 50 and negative 25, but 50 was from the positive x-axis, so I could throw it in and not think about it. Negative 25 was from the positive x-axis. I could throw them in and not think about it. As long as your angle is from the positive x-axis, it's ready to go. Put it in sine, cosine, and tangent, whatever. And of course, make sure that your numbers make sense. This was 900, and this is 350. That makes sense that that could be about 1,046. If this was 50 and you're bringing it down a bit, 31 makes sense. Your number should be, I mean, your picture's not great, but your pictures should give you an idea if your numbers are in the right ballpark. All right, any specific questions you want to ask about setting all this up? Did you all get that right? Without me going over it?